Hi everybody, my name is Bhavisha and in this lecture we'll see the concept of virtual links. So before that we have to revise what is our backbone area, what is non-backbone area, and why we always connect a non-backbone area to a backbone area, right? Yes. So as you can see in this topology, here I'll explain bit by bit. So R1, R2, R3 is connected together and is under area 0. Here in this topology, here in this area 0, our R3 is the only single area router. Single area router are those routers where their interfaces lies in the same area. So it's both of the hinges or interfaces are in tier 0 only, right? And also if we look at area 2, so in area 2, our router 5 is also a single area router as its own interface lies into area 2. If you look at R4, R4 is also a single area router and R6 too. But if you look at R1 and R2, so they are performing as area border router as they are both of the hinges or both of the sides are in different networks simultaneously and also in different areas. That would make it ABR, R1 and R2. And the concept says that every non-backbone area should at least have their one router or one interface connected to backbone area, right? That's what make the connection possible because area 0 works as a connectivity between two non-backbone areas and it's a mandate too. So far this is what we have learned. Now I will make a new topology here and there we'll see what are virtual links. This topology was possible because it was in equilibrium that both of the areas were connected to our area 0. What if there is a topology where one area is connected to non-backbone area is connected to a backbone area, but another area, let's suppose area 2 is not connected to our backbone area. Then what will happen? Let me change the topology. So this is our new topology. Here we learn the concept of virtual link. So as you can see here that a non-backbone area is connected to a backbone area. Perfect. But our another non-backbone area is not directly connected to our backbone area. So in this case, as we are unable to move our topology physically to connect it to our backbone area, so what we will do is we'll introduce the concept of virtual links here. So we will virtually link to ABR, area border router, of different areas to each other. Let's suppose this is R2, ABR connected to area 2 and area 1. This is our another ABR having area 1 and area 2 simultaneously. Now let's suppose there is a router in between. So what we'll do is we'll go to R2 and we will virtually connect R2 to R4, and that virtually connection is that the R2 is going to be directly connected to R4, which is directly a part of area 0, and R4 is also directly virtually connected to R2. So this is called as virtual links. So we connect virtual links in a scenario where a non-backbone area is not directly connected to our area 0 physically. But in that case, we provide virtual links from one ASPR to another ASPR to bridge the gap between non-backbone and backbone area, right? So we give it the connectivity it needs without physical connection, right? So if we want to conclude to the concept we have learned already, that is that every non-backbone area should get attached to a backbone area either directly, this was the previous concept, and now the new concept says either directly or virtually through virtual links, right? Yeah, so this was the concept of virtual links. I hope you enjoyed.